in the whole world in 1960s. So within 2 years, within 20 years, we captured and we started to do work there. And here, towards ubiquitous GIS. Ubiquitous GIS means GIS is everywhere. Initially, GIS is not everywhere. Tabletop GIS was there. Wherever I have a computer, wherever a thing, I can do only that itself. When you have a software, now software is open source. Anybody can use it without paying any money. But those times, if you have a money, then only you can buy a software, then you can do your GIS. It's very difficult for us those times to use GIS, and doing map was very difficult using GIS. Now it's not like that. That's why towards ubiquitous GIS. And good example is WebGIS, web-based GIS. And this is GIS trends. These GIS trends are, changing the world. Janger Mood, is the president of ESRI. According to him, he has listed these things are trends, major trends in GIS. Many trends are there, but according to him, location as a service, advanced analytics, big data analytics, real-time GIS, mobility. Then finally, I think yesterday Dr. Surendran explained about artificial intelligence in GIS, virtual reality and GIS. These things are now growing in geographic information technologists. So location as a service. If you see here, there was a time when GIS use was limited to the niche market of government, telecommunications, utilities, oil, gas sectors. That market has grown substantially as large retailers and tech startups have seen benefit of understanding the data spatially. So initially different government departments they started to use, particularly like a PWD and land department, they try to use GIS or map making, particularly like Canada, USA, then northern part of Europe. For them it was very difficult to map all those things using different types of satellite data. They captured everything, they started to use GIS. Initially it was by government institutions, universities and other academic institutions. They did so much of work in the field of GIS. So location as a service means good example is LBS, location based services. Now whatever things we are getting, that is based on the location based service. Amazon, when I want to order any product, I will order through online, then Amazon will give you within a day or within 2 days depending upon the location where you are actually. So LBS is a very important technology, and commerce people, management people, business people, they are using LBS as an important and efficient tool to deliver their goods, to complete their task. And now business analytics is a very high technology. With business analytics, now they have added location analytics, very important component. Using that, they will be able to deliver all the goods within a particular time. Another one is big data analytics. Yesterday, madam also little bit he explained about what is really meant by big data analytics. The ability to access the vast amounts of data that provide us with insight into environment and human behavior and change the way all organizations function. It is nothing but integration of big data operations into spatial analysis. Big data analysis is a part of computer science, and nowadays we are generating so much of data, millions of data. We have a social media, we have an internet, lot of data are being generated. Particularly social media, I can upload any data, any video or audio in social media, Instagram or whatever Twitter is concerned. So much of data is being created. How we are going to handle that? We are going to store all the data. It is very, very difficult to handle the data. It is very difficult to analyze the data. For that, big data analysis has come. And as a geographer, as a geospatial scientist, we have a large databases. Our satellite data, we have a 1 meter resolution, we have a 5 meter, 3 meter, whatever meter. It is not that much easy for us to store the data, handle the data. So big data analytics plays a great role in handling spatial data. So the latest trend in GIS is, or geospatial technology, is big data analytics. If you see here today, anyone in the enterprise can access billions of environmental observations, or tens of raster images from spacecraft and analyze them very easily. So the trend is big data analytics is a very important technology, and we try to analyze it. Another one is real-time GIS, real-time. Those times if I want to collect data, no, I have to go to government agencies or some private agent, I have to collect the data, I have to enter in the GIS environment, then I have to prepare a map. I can see what about the traffic flow yesterday, before yesterday, today morning, and what is the temperature, what is the rainfall. Based on the collected data, I will be able to prepare different types of map, whether it's a 2D or 3D, based on the data I will be able to do it. But nowadays, we have a real-time data. There is a term, Internet of Things, IoT. It is also part of computer science. As a geographer, I will be able to use IoT, I will be able to use virtual reality, I will be able to use artificial intelligence. Then I will be able to do it. Yesterday, I think Madam told car driving, right? I can drive a car, but I don't know anything about the infrastructure. I mean, whatever the things are there, no need about it. My aim is to drive a car. Same thing, my aim is to analyze all type of data, how I can use IoT-based data. So this is real-time data. If I want to see now what is the traffic now between University of Madras and between Tamil Nadu Open University, I will be able to see real-time. Where I was high, where is very low, then I will be able to select which route is the best route for me to travel from one place to another place. These type of real-time data will be very helpful to prepare real-time map making. So this is the Internet of Things. If you see here, application of Internet of Things. And here, for example, if I have automated weather station, now we don't have automated weather station so many places. We collect data, then we prepare, we do interpolation, we will be able to see where rainfall is high, where rainfall is less. But when I use these automated weather stations, if I am going to install some 100 locations in Chennai city or 50 locations in Chennai city, it is connected with internet. Wherever rainfall is there, wherever temperature is there, automatically that will be collected. Using the internet technology and other technology, I will be able to see and visualize the real data analysis. So, Internet of Things will help you a lot in these areas. If you see here, in telecommunications, cities, buildings, environment, public safety, weather, airports, airport is very important. When they want to control the air traffic, IoT will be very, very helpful. What is the role of geospatial technology, people? And geospatial technology is a very big subject, but how you will use it all depends on your expertise. I may be a human geographer, you may be a physical geographer, maybe agriculture, maybe urban geographer, maybe health specialist. It all depends on your expertise. You will be able to use these things for solving the problems. So these are all the major applications around the world. They are using IoT, smart logistics, smart water management, smart healthcare, smart transportation. Many places are being used by government authorities and private people, so that you will be able to see the reality, you will be able to take perfect decision for solving the problems, whatever problem you have. Another one is mobility. And if you see here, it's not now just desktop GIS. You can have your mobile, you can have your laptop or iPad, you have your software, you will be able to capture the data through online. You will be able to use web-based GIS software, you will be able to analyze everything. You can see everything here. Wherever you go, you will be able to do it. That means mobility is there. Your GIS is everywhere. Your analytical tool is everywhere. If you think GIS software is an engine, engine is with you wherever you go. That means the mobility is, everywhere GIS is there. Anybody can use it. There is no need to understand so much of technical grounds. So this is an example of map. If you see here, based on the analysis of 7 years data, they have prepared this. Traffic accident data. The analysis considers many factors associated with accidents. So this is accident map, and the artificial intelligence they have used and they have prepared, and variables are weather they have taken as a variable. Time of the day, which time is worst time for the accident. Speed limit, whatever the speed is, 60 or 70 or 80. Then proximity to an interaction, then route characteristics. That means route quality. So we simply tell accident is happening because of drunken people, are not like that. You have to see all those variables, then you will be able to analyze your accident data. This is another one. Roads can be detected using deep learning and then converted to geographic features. So you have a built-up area, and using your artificial intelligence, you will be able to map the roads. This is building footprints extracted out of satellite imagery. Then again, using your artificial intelligence, you will be able to map. When you are able to see the map, building footprints, if I want to install, solar panel, based on this I will be able to select which area, which building is suitable for installing solar panel, household based. And this is augmented reality. So nowadays everybody is talking about, augmented reality. If you see here, it allows you to interact with the outside world by enhancing or adding 3D features to your phone display. It is a very important technology now. It's growing now. Particularly geospatial scientists, they are just entering into this field. This virtual reality takes information like us. You can use your satellite data, or you can fly using your drone, you can capture the building and some of the area, you can convert that into virtual reality. That is a separate technology. I think one of my students is doing this research. So using that, how we are going to visualize, how we are going to understand particular landscape. In virtual reality also, you will be able to measure the distance, you will be able to measure the volume. That research is going on now. So this is a handset, and you will be able to visualize it. We have a virtual reality lab in University of Madras. We have a website. I think if you are going to use, you will be able to see what things are there. Reality means, if you have that class, you will be able to see that. If it is a mountain area and whatever, you will be able to visualize, understand perfectly about it. In teaching and research, virtual reality plays a great role. So the geographic approach, if you see here, using your geospatial technology, and if you see here how you are going to get it, creating, measuring, organizing, analyzing and modeling. You analyze everything, then after that, based on the data, you predict. That is how you are going to predict based on the earlier data, existing data. Using geospatial statistics, we can predict for 10 years, 20 years what will happen. If population goes like this trend, what will happen another 10 years? If crime is happening like this for another 10 years, these 10 years, based on these 10 years, based on the behavior of the people, based on the government decision, what will happen another 10 years? What about the crime rate? So you can do modeling. Then we have a holistic, comprehensive, systematic approaches to visualize geospatial data. So geography integrates into how we behave. Actually, behavioral science is very, very important subject. Psychology and criminology are very, very important subjects. Those people also look at geographic information system, because you can prepare a, perception or attitude, whatever things are concerned. This is an application of GIS. I think this is a flow map. Map is visualizes movement of people between places, often across a large region, even the entire globe. You see here, migration is going on from this state to that state, and where, how much. You try to visualize so that you will be able to understand where in migration is so much, where out migration is so much. Your GIS will visualize perfectly based on the data. So, future trend in geospatial information management. Now it is a smart cities. Almost all over the world, smart cities project, they have taken GIS as a very important tool, and Internet of Things, artificial intelligence, big data, indoor positioning system, those are all part of geospatial technology. Indoor positioning system is a separate system. When you have a very big mall, when you want to locate a particular shop or a particular thing now, using GPS is a little bit difficult. It's a specialized technology. They have a GPS and they have a Bluetooth and other technology. Using that, you will be able to map within the malls. So location analytics now plays a great role. And this is, geospatial capabilities are being integrated into all kinds of systems and tools. So initially traditional GIS is now disconnected. Trend of consumerized application enterprise now has done. And if you see here, whether it is business or society or economics, everything, the basic platform is location. Location context plays a great role. So, the science of where is advancing rapidly. The science of where is nothing but location. The science of where is advancing rapidly means location plays a great role. If I want to analyze that, geographers are the best scientists. Using the geospatial technology, you will be able to, identify the problem and solve the problem across space. And if you see there, many things are there, integrating, leveraging, many innovations are there. And this is an ArcGIS. ArcGIS is a world leader in geospatial technology. And you can see the machine learning, distributed computing, LiDAR, then scientific, so many things. You try to put everything in cloud. The data will be in cloud, no need to take data from one place to another place. The cloud computing is another technology everybody is using, and as a geospatial scientist, we have to use, we compel to use, because large data, large space of data can be anywhere. You can use your cloud and you can extract the data, you can do your analysis. Whether it's a raw data or processed data, or if it's a map, after completing everything, your output also will be in the cloud. At any time you can take the data for any type of analysis. So the science of where the location, the location analytics plays an important role. Many people will ask you, geology means what they study below the earth. Physics people, that mass, chemistry, anion, cation, geology below the earth. Anthropology about human being, sociology, sociologist, economics, demand and supply. What about geographers, specialization? Many people normally will ask, what is your specialization? It's very difficult to tell your specialization. Maybe I am a social geographer, then I can tell social geography. But as a geographer, my specialization, as far as the subject is concerned, it's very difficult to define. Everything is mine. Then they will tell you are not a specialist. Right? Botany will tell, I am a botanist. You study biogeography. Geologist will, I am the specialist in geology. I am tell zoology I am studying. Economic geography is there. I am economist. You don't know anything. You study a little bit and you are telling I know economics. See? Geography is not based on the specific body of knowledge. Geography is based on a technique. Geography is based on a tool, that is spatial analysis tool. And whatever I am talking, everything is spatial analysis. Whether it's location to location or distance or area, everything spatial analysis. We try to analyze everything spatially. Whether it's a micro level or a macro level. Otherwise, at this university level, Chennai level or Tamil Nadu level, India level or global level, everything is space. United Nations Secretary will analyze globally which country is bad, which country is good in terms of crime. For our Prime Minister, he needs state-wise. For our Chief Minister, he needs district-wise, district collector, taluk-wise, taluk, village-wise, revenue village. For revenue village, you have village administrative officer. For him, lot of hamlets are there. You see, micro level to macro level. So for that, you have to capture different types of data. So geography is like this. Who are you? You are a regional geographer or, micro level, or you are going to analyze what I said, very small area. It all depends on that 1 centimeter level accuracy drone data or 30-meter resolution. We will be able to do it. Specialization is spatial analyst. I am a geographer, I am a specialist in location analysis. I know where I have to have departmental store, where I have to have a wine shop, where I should not have a wine shop. Geographer only will be able to do it. I know human dimension, I know physical dimension. Now I know geospatial technology. I have to learn something about, computer technology, this big data or data science or some machine learning little bit, so that I will use those things as a tool for analyzing the spatial data. Cartography is a subject for me. I have to understand, as a geographer, I have to understand cartography. I have to develop the concepts, principles, frameworks, and I have to bring new concepts in the field of cartography. Normally I used to tell my students topology concept. Yesterday Professor our CM sir also mentioned about it. It's a very big subject, branch of mathematics. Normally every time I will tell this. This is from mathematics. We brought from mathematics, we develop in cartography. Without topology you cannot do mapping now. Like that, as a geographer we have to develop the subjects. Cartography is a subject for me. Map is a subject for me. For other scientists, it is a tool for analyzing, for representing different types of variables. Like that, this artificial intelligence, this IoT and other things are a tool for us to explain our parameters. If I want to do land use, land cover, I can use deep learning as a tool and I can prepare a map so that I will be able to give accurate land use, land cover map. So, the location analysis is a very important thing now. So maps are mandatory for government now. From government to business, where location adds value, how to take advantage. Government without map, nothing. They cannot do anything. Okay, because the land is very important resource. And this is elevation. When you want to analyze the characteristics of a land, terrain, then we can do 2D, 3D analysis so that decision maker will be able to understand what type of land is there, land quality is there. In atlas, we had the initial paper atlas. Because of this geospatial technology now we have living atlas. We have electronic atlases, dynamic atlases, interactive atlases. Many atlases have been developed international level. Different countries they have developed atlases. If you go and see, you will be able to prepare any type of map. United States of America, they have a national atlas actually. They have a lot of data from United States. You can select one particular state and one particular data, then you can prepare online interactive atlases. Because of this geospatial technology, you will be able to capture the data as on today and you will be able to map anywhere. Web-based GIS. So location has become omnipresent. So many social media tools use location whether we realize it or not. Many people, we upload the video, we upload different types of data, that itself, they know where exactly it is. Knowing or unknowingly they use data. They create a data. So map is not like a private, it is omnipresent, it is everywhere now. So Google map is there and wherever I go, whenever I want to drive, I have to use that. How much time it take to reach a particular target. Sometime it's not a geographic, 10 kilometers, how much time? 10 means 5 minutes, it all depends on the traffic. Your map will tell you it will take some time to reach a particular place. So your map is everywhere. Your GIS based map is everywhere. Location is the new champion of analytics. Analytics means everywhere. Every subject expert, they are doing analysis. Now, without location, if they do analysis, that analysis will not have any meaning. If police is telling so much of crime, 20% crime has been increased in Chennai, that's not right. In Chennai, which part of Chennai? Which time crime was so much? You have to exactly identify and tell, otherwise you will not be able to solve the problem, you will not be able to mitigate. A location platform integrates and connects everyone. If you see here, knowledge workers, executive access, public engagement, work anywhere, enterprise integration, finally geospatial professionals. When you use geospatial professionals, you will be able to improve the communication, collaboration so that your work will be perfect. And you have so much of data and you try to have your map like this. Every minute you can change the data based on the IoT data. When you have changing pattern of data here, map also will be able to change. So that you will see the real status, real time a pattern of traffic or pattern of anything. So enrich your analysis. Your data is with reference to location, and if you see here, your maps are here. All the layers, different maps, business data, lifestyle data, demographics, and so much of data you have for this particular area, and you can prepare different types of maps. And this is table, and this is pyramid. You can have different types, multimedia map. Normally people will tell multimedia map. You have a map, you have animated map, you have a table, you have a video, you have audio. That means using multimedia map, you will be able to explain perfectly about a particular problem. This is an example, market planning and analysis. It is in business and commerce. Customer and demographic analysis, research and development, expanding international markets. You can do your forecasting. You see here your maps, and you will be able to see the location of your customers and everything. We are thinking GIS is engineering technology subject, and it is for geographers only, or it is for science people only. Not like that. We have to give admission to all people actually. When I want to start MTech, no, I want to give admission to everybody. Initially only for jobs, that's not correct. Engineering, geographers, economists, commerce people, whoever is interested to do MTech geoinformatics or MSc geoinformatics, we have to give admission, because geospatial technology is like a computer science. It is like a mathematics. Anybody can use it. How computer science? Computer is very important for me. Without computer I cannot do this. Computer is a tool for me. Mathematics strategic, without it can you do any analysis? You cannot do. Now, geospatial technology is like that. Location analytics is like that. Anybody can do it. That means we can give admission to anybody. Anybody can become a geospatial scientist. Geospatial scientist. They can take their data, sociology, they can take their data, they can locate, they can prepare different types of that, they can take decision based on the location. If they don't know the location, sociologists will not be able to solve the conflicts between different groups. So, everywhere it is. So, where should we place our distribution centers to minimize cost and maximize our reach? I mean, a businessman or a departmental store. Any big businessman, he wanted to have different types of branches of departmental store and any other branches, and he has to think, what about my service area? Normally we have a Thyssen polygon, that is we use for that. Proximity to customers, suitable transportation. See here, now if we visit any departmental store, they will tell within 1-2 kilometers we will deliver free of cost, right? That's a good example. We can prepare this. So, GIS plays a great role in business analysis. And this is geo-enabled business. You can see here operations planning, production and operation, risk management, performance management, distribution. Maybe those days they didn't give any importance to location. Now they give importance to location. They have added. It's embedded. Location analytics software is embedded with business analytics now. And you can use your location, apply your location. That means apply your geospatial technology everywhere. You can see here IT and infrastructure, price optimization, social media analysis, customer survey, and everywhere you can use. Anywhere, there is no limit at all. If you know this subject, if you know I want to add the location as a parameter to analyze this, then I can use it. There is no limitation at all. It is like a N. It will go, I can use anywhere. And this is another one. Market planning is there. Distribution, where I can store. Your Amazon is a good example for this. What about their marketing places? What about their store operations? Where they are merchandising? What about their distribution of all goods? Wherever we want to do. Retail and location. You see the application of geospatial technology here. Real applied geospatial technology. Without realizing, we are enjoying this application of geospatial technology everyday's life. everyday life, right? Why is location so compelling now? Map communicate very easily. I think I need not explain you that, okay? Instead of reading 10 pages, one map is enough for me to understand the reality. And I will not forget. If I know map, if I able to see the map, some spatial distribution of something, like a crumb, I will not forget. If I am going to read 10 pages, I will forget. I don't know what is happening. So, spatial analysis is powerful. New technologies making location very easier. So, new technologies, these technologies, spatial analysis is real geography, map, we use everything, we represent as a map. And here, map is a tool and map will communicate. So finally, we have artificial intelligence, those intelligence. Now I can tell location intelligence. Our geospatial, we are the location intelligence people. Okay. For retail industry, example, and we can see here, right? Food traffic analysis, human mobility, mobile location data analysis, IoT and indoor mapping, retail store location analysis, everywhere. And example is from industry, because they have to use and they have to realize geospatial technology is a very important technology. And you will be able to see here, guy is here, and you will be able to use his iPad. And if you have your virtual reality about this area, you will be able to understand what is going on, what are the things are there. It has full of information about this area. If you know full information about this area, I think you will be able to take very good decision. Anyway, this is okay, so technology is driving geospatial industry. So one is the cloud, infinite power of computing. So we are using now. And Internet of Things now, everything that can be connected will be connected. You will be able to get real-time data and big data, insight about every aspect of our lives. So automation and robotics improve productivity. This is coming and I think it will take some time to do it. The application of geospatial technology, I think you know that there is no limitation. Everywhere, anywhere you can use it. It all depends on your expertise. You know a little bit geospatial technology. If you are expert in agriculture, you can use in agriculture. And if you are an archaeology guy, archaeologist, yes, it's a fantastic tool. Till now nobody is using. I mean, archaeology people. They don't know in their curriculum, they have not included. We have archaeology department, ancient history and archaeology. Many times I really discuss with that HOD, sir, please include GIS as a tool or no. At least please send your students to our department. No. And this is the time for us, I think particularly teachers, we have to give awareness to first academicians. Actually, I am discussing with many people, the management department, the commerce department, because management department is very important. Once management departments include geospatial technology as an important elective, maybe it is a core for them. Commerce also, then all IIMs, all IIT, they will include GIS as an important subject. So we have to think so much about it so that, our people will be able to get a job everywhere. Maps are becoming less optional for business now. So you know that. It's not optional now. Optional means not like our optional subject. It's a core, like a core subject. It's compulsory. Without that you can't survive. You can't expand your business. You have to do it. You must do it. So visualize your data, enable spatial analytics on dynamic data in order to drive decisions. That means because we have a real-time data, and we will be able to use that as a dynamic data because it will change. It all depends on that. If I am going to do traffic mapping, every half an hour and 10 minutes, I can do my mapping. It's a dynamic. I will be able to see that based on that I will be able to select my roads. Instead of this, I will select this road, this road, this road, so that instead of 1 hour, I will be able to take only 30 or 40 minutes to reach a particular place. So location strategy. So we need to use this. Again, now go from government to business. Different patterns of diffusion following consumers' expectations. Where location adds value, how to take advantage with an experimental followed by a structure of that means everywhere it is local government to national government, local business to national business. Like now we have this digital era, digital initiative. If I want to pay money here, I think GPay is enough for me. Digital is also towards digital. So obtaining a reliable solution based on scientific method for all geographical matters is consistent and in line with our core values. That means the science of where is playing very important role. It will play a great role in all parts of our life. Whatever subject you take, whatever business you take, without that it's very difficult. Now we are a data-centric geographers. Without data you cannot do it. Geography is an analytical subject. Without understanding mathematics, statistics, computer science, you will not be able to survive. So many things are there. Critical thinking, scientific communication, community building, entrepreneurialism, profit awareness. If you think business, economics, commerce, no, everybody's profit motive. But that geospatial analysis will be very helpful. So, geospatial technology is a technology, gives so much of information, helps to understand the reality, whether at micro level or macro level, and whatever problem from social science, earth science, physical science, biological science, whatever thing you think, no, your geospatial technology is there. And finally, it's a tool for many of the people, and they can use and we can use for solving any type of problems. So thank you very much.
So good morning to everyone. I have to thank Jagannathan sir because the what we think and what we need, because as a student and teaching from 2000 onwards, so it has many of us senior professors and my colleagues has got a blink in the mind, so what to study tomorrow and day after tomorrow. So I find the great thirst is found there. It's a wonderful presentation. I want to put myself in very advanced myself because the topic was given to me after this session sometime afternoon was really what's the curriculum issues in geography. So we are in 100th year of teaching. So I felt I was very happy because my senior, one of my mentor, has put my path is very clear. The word he used, analytics. Actually, the time has come for the geographers to reorient ourselves, what to learn by our student and what to teach to our students. So it is, the time has come. So otherwise this bus will go. So many people are standing outside. So with this I thank Professor for giving a big lead to the young minds and faculty members. So any clarifications, questions you can ask Jagannathan sir. So meanwhile I can call upon the two presenters, Meenakshi and Shweta. Meenakshi will start this presentation. Meenakshi.
a warm good morning to one and all present here. So myself Meenakshi J from Bharatiya University, final year integrated MSc Geography. So today I am going to present about the geospatial analysis for soil erosion assessment using morphometric prioritization in Chaliyar watershed. So soil erosion. Soil erosion is a gradual process where soil particles are detached and transported by wind, water or other forces. It is a significant environmental issue impacting agriculture, water quality and ecosystem. Human activities such as deforestation, overgrazing and improper land use are exacerbated soil erosion rate, leading to degradation of fertile land or loss of biodiversity. So here I used morphometric. Okay, sir. So here I used morphometric parameters and common factor to detect morphometric parameters and common factor to detecting soil erosion. So next. And this is my aim and objective of my study. Aim is to analyze soil erosion in Chaliyar River, Malappuram, Kerala through morphometric prioritization using Cartosat dam. The Cartosat dam is from within the website, and objective is to delineate the sub-watershed in Chaliyar watershed. And to understand the morphometric characteristics in each sub-watershed to select suitable direct and indirect factor of sub-watershed prioritization to generate selected morphometric parameters, and finally using common factor finding soil erosion map. Next. And this is my study area. My study area is Chaliyar River Drainage Basin, covering 2,923 square kilometers. It is situated between Murat and Kabani basins in north, and I here put latitude and longitude. It spans across 4 districts such as Kozhikode, Wayanad, Malappuram, Nilgiri district of Tamil Nadu, and it is slow southwest direction and ultimately empties into the Arabian Sea. Next. And this is my methodology: acquire Cartosat dam, extract morphometric dataset, drainage extraction, morphometric attributes, watershed properties, stream ordering, and I used linear aerial relief parameters and estimation of CF using morphometric parameters, and finally erosion risk assessment. And these are the formulas I used in my study. Next. And this is the delineation of watershed to sub-watershed, acquire Cartosat dam and boundary in RQGs, fill, flow direction, stream to future, stream order, flow accumulation, pore point, and convert the graphics watershed, sub-watershed delineation. And this is the prioritization of sub-watershed. I use direct parameters and indirect parameters. Direct indicators are directly correlated with elevation soil erosion, as higher value signify increasing vulnerability. And conversely, indirect indicators shows an inverse relationship, indicating that lower values are associated with heightened susceptibility to soil erosion. Next. And these are my morphometric parameters result. Next. And these are some of the map I put here. Linear aspect. For linear aspect, I show here bifurcation ratio, mean stream length, length of overland, sinicity, infiltration ratio, basin length. Next. And this is for radial aspect: stream frequency, drainage density, drainage texture, form factor. For relief aspect, I here put ruggedness number and relief ratio. Common factor. It is refers to as a composite metric created by combining multiple morphometric characteristics of a river basin or watershed. It is a quantitative measure that describes physical attributes, size, shape, relief feature of drainage basin. This common factor is typically calculated by assigning weight to selected morphometric parameters and then assigning these weighted values. It provides holistic understanding of river basin behavior, allowing for more informed decision making in areas like soil erosion, flood risk assessment, land use planning and watershed management. Next. And these are the common factor calculation. I use 8 parameters such as bifurcation ratio, drainage density, stream frequency, drainage texture, circulatory ratio, elongation ratio, length of overland flow, form factor, and finally common factor. Here also I put a rank here. Next. And this is my final map. It is also inversely proportional to soil erosion. That means where is the common factor here? there is the low value for common factor, which area is more chances to soil erosion. It means subwater 1 and 3 is the less value, so there is a chances for high soil erosion. And subwatershed 2, subwatershed 6, 7, 9 are the moderate chances to soil erosion. And next one is subwatershed 4, 5 and 8 is the low level of soil erosion. Next. And conclusion, the identification of specific subwatershed within Chalia River Basin based on comprehensive analysis of morphometric parameters and common factor is a pivotal step in soil erosion. It offers detailed understanding of basin's physical characteristics and implication of flood behavior. And these parameters guided the identification areas varying degree of soil erosion, enabling tailored approaches to soil erosion management. And these are my references. Thank you.
Now this paper for discussion. So my comments first. When you show maps, you should interpret it. Okay? Don't say this is form factor, this is, everybody know this form factor. So you should say there is high, low at least. Okay?
Half of your things are relating to measurement of the height, right?
Yes.
Slope, etc. You have measured. Dissection index you have measured in terms of the height, elevation.
Yes.
Elevation you got it through the remote sensing or through the map?
Through a DEM.
Huh? DEM. DEM, you created DEM from the Bhuvan?
Yes,
okay. Now the point is, what is the vertical accuracy of the DEM? What is the horizontal accuracy of them? Did you ever notice the vertical accuracy and horizontal accuracy of the Cartosat data? Isn't?
Yes,
yeah, that ratio is always not compatible. Now, unlike your map in 1:50,000, 25,000 map, it is compatibility. The vertical height varies from 100 meters to 50 meters to 10 meters like that, etc., depending upon the scale of the map, which is not there in the your Cartosat DEM data. So if you have taken, okay, otherwise I think you have to take care of all those things. Because this digital data, there are two things. One is this horizontal, another one is vertical variation. Anywhere, even LiDAR data also, the vertical variation is more accurate than the horizontal variation. It won't compare. So that point is very important when you are considering the digital data of different sensor, etc. And the sensor used in Cartosat is very obsolete. That's what I can say, because the vertical variation is jumps many times. It is not very uniform. These are all the factors you have to be considering. Okay, thank you.
So okay. So a little bit correction to be in your presentation. So don't put in this morphometric. So just added that drainage morphometric, one thing. So your flowchart will be mentioned that the linear parameter, aerial parameter and the relief parameter. So generally is as according to the Hutton or a Staller has mentioned that linear aspects, aerial aspects and the relief aspects. You should add that. Then stream ordering, what is the scale, how to delineate, what is the scale of the delineation of the stream ordering? So then you have to use some lot of ratios. Just to interpret, suppose the length ratio, so between 0.69 to 0.79, what is the interpreter on the watersheds? Just to mention that, So we have lot of interpretation techniques as given by the Staller method or Hutton method is there. So try to read on that R.P. Mishra and Sharma book is there. So perspective geomorphology. So book name is. Okay, sir.
Mathematical analysis. I think she got this